We started class today with your group brainstorming at least 3 different real-life situations where you would want to estimate rather than getting an exact answer. And I gave you some hints there with some Google images, but in your groups you guys came up with some really great examples. And then we talked about why are estimates needed. And here's one reason. An exact number might not be worth the trouble it would take to get it. For example, if I'm a sports reporter and I'm telling how many people attended the FIFA World Cup, I don't need to know down to the nearest 100 people. I could just say about 78,000 people, and that's worth it. It's too hard to get an exact count. A second reason is that an estimate might be easier to work with than an exact value. For example, I want to know the cost of these 6 items. If they're €4.95 each and I want to calculate their items quickly, I just think of 5, and 6 times 5 is €30. I don't really need to know the exact amount. It's easier to work with 5 times 6 rather than $4.95 times 6. It might be safer to use an estimate. So I'm planning my wonderful Bali holiday, and I am estimating that I'm going to need about €170 per day for my expenses on my trip, for my food, eating out, my entertainment, going out on a boat ride, etc. So I want to be safe and make sure I don't run out of money on my holiday. So I might round that up and budget €200 per day. An exact value is going to change from time to time. For example, the population in France in 2005 was about 61 million people, and that's definitely going to be different in 2014. I would guess that France has increased in its population. Some countries actually have decreasing population, but as many of you said in class, every day people move, people are born, people die, so the exact value is going to be changing from actually day to day. And then an exact value might not be available. So I'm planning on going somewhere or saving my money to buy some expensive item, and I'm planning on saving €850 in 3 months, but I don't know for sure if I'm going to be able to do that. Maybe I have an unexpected car repair, or I need to fly home because my mom got sick, or some other unexpected expense, so I don't have an exact value available, so I'm going to have to estimate. Okay, so when you round off a number, you do that many times so that you can then calculate in your head. When you're making an estimate, it's just easier to calculate with a rounded number than a precise number. So for all those reasons we just gave, there are times when you just don't need the exact value. So there are 3 different kinds of rounding. You can go to a lower value, and you'll see an example of that in a few minutes. You might want to round up and go to a higher value, and again, there'll be an example of that in a few minutes. And most of the time in school, we find the closest value on a number line, which is rounding to the nearest, and that's the most common that we do in school. But in problem solving, sometimes you need to round down, sometimes you need to round up. And we talked about an example if we were planning a 6th grade field trip, and we knew how many students will fit on each bus. And so we took all the students and divided by the number of buses. Well, no matter what decimal we get, we would need to round up, because we wouldn't want anybody to not be able to go on the trip because we didn't have enough buses. But if I asked the question of how many full buses are there, then I would round down, because that amount of unfull wouldn't matter. Maybe we were going to take buses and then a few cars. So it really depends on the real life situation as to whether you round up or round down. In school, most of the time, though, we round to the nearest. So to really round accurately, you need to understand the meaning of rounding a number to a specific decimal place. So I picked pi because, remember, it's an irrational number that never repeats and never ends. We cannot express it as a fraction. And so this is an approximation for pi to several decimal places. So we use that to practice rounding off. So I wanted you to round pi to the nearest whole number, the nearest tenth, and the nearest hundredth. So you made some number lines, and then I had you come up and put those on the number lines. And then we talked about the number pattern, so you don't always need a number line. But if I want to know to the nearest whole number, I know that 3 is on the left and 4 is on the right, and I had everybody count by tenths, so we had 10 intervals between 3 and 4. and 3.14 is right around here, and we can see that it's definitely closer to 3. The middle of 3 and 4 is 3.5. So when I look to the right and I see this 1 in the tens place, that tells me I'm to the left of the middle because 1 is less than 5. And therefore I know that really to the nearest whole number, this whole number for pi is closer to 3. To the nearest tenth, I want to know, is it closer to 3 and 1/10 or 3 and 2/10? So on my number line, if I put 3 and 1/10 and then 10 intervals later 3 and 2/10, in the middle is 3 and 1500ths, because 1/10 is the same as 10 hundredths, and 2/10 is the same as 20 hundredths, and in the middle of 10 and 20 is 15 hundredths. And I want to know where 3.14 is. So it is a little bit to the left of the middle. So it's going to be closest to the nearest tenth to 3 and 1/10. To the nearest hundredth, I'm asking, is this number closer to 3 and 14 hundredths or 3 and 15 hundredths? And again, if I tack on a 0, it helps me find the middle is 3 and 145 thousandths. And 3.141, okay, that 1 tells me that it's over here. And so my real number is around here, so to the nearest tenth, it's closest to 3 and 14 hundredths. So placing the number on a number line is really helpful to seeing its nearer number. Okay, then we use rounding and problem solving, and you don't always round off in the same way, so it really depends on the problem. So this was about Abby's bakery. She has 5 eggs in every cake, and she's making 25 small cakes for a banquet, and eggs are only sold at her market by the dozen. So the question is, how many of these dozens of eggs, egg cartons filled with 12 eggs, should the bakery buy? So I heard your groups, you guys discuss this, and most of you said first find out how many eggs. You need to be exact on that. So 25 times 5 eggs is 125 eggs. And then we talked about, do you really need to use your calculator? Can you estimate here? Well, you know that 10 dozen is 120 eggs, and 125 is 5 more. We know a dozen is 12, so if we get 11 dozen eggs, we're sure to have enough. We're going to have 7 extra, but that doesn't matter. For solving this problem, I just need to know I need to buy 11 dozen of eggs. In this problem, we worked with oranges, and they're being packed in crates. Each crate holds 144 oranges, and you have to pay very close attention to the question. How many crates can be completely filled? I'm maybe selling these to grocery stores, and they only want full crates. Well, I had you guys estimate in groups, and some of you said 10, and the highest estimate was 100. So we talked about how you think about this. You could all multiply by 10 easily. So 144 times 10 is 1,440 oranges, and that would be 10 crates of oranges. And if I want to know what that is times 11, I'm just going to add an 11th group, so another 144 to 1,440, and I can see that 11 crates will hold 1,584 oranges. Now my question asks, how many crates are completely filled? I don't have these 84 oranges to fill the 11th crate, so my answer is 11 crates. Now if the question were different, if it said how many crates are needed to hold all 1,500 of my oranges, I would need 11 crates. Now the 11th one would not be full. So this is an example of where you have to interpret the question. Should you round up or round down or round to the nearest? Okay, then we talked about what banks have to do. They're going to round down any fractions of a cent for interest, which is money they're paying you for having your money in their account. They don't want to lose any money, so they're always going to round down. So if this is how much interest you had, we don't have a coin for 1,000th of a euro, so they're going to drop that. They're not going to pay you an extra 4,000th of a euro. They're just going to drop it, and they're going to round down to 15.73 euros. In problem solving with gasoline, so let's say that the gas station pays this much per liter for their gas. So I said, estimate how much money the gas station will charge for buying 48 liters to fill your gas tank. Some of you rounded before you multiplied. You said, okay, it's going to be $1.58 per liter because the gas station's not going to lose this 2,000th of a euro. So they're going to round up to $1.58. And if you multiply by that 48, we get 75.84 euro. And some of you said, no, they would multiply by 48 first. and that's 75 euro, 456 thousandths of a euro. No matter what this number is, they would round up because they're not going to lose whatever amount is in the thousands place. So they're going to pass that charge on to you, the consumer, because for you it doesn't matter if you pay an extra cent. But imagine the gas station with thousands of customers a month buying many hundreds of liters of gas. That would add up to be a lot of money for them if they lost that whatever numbers in the thousands of a euro. So notice the difference here. If you round off before you multiply, you get less and less accurate because we did that rounded off part 48 times. So really, since you can calculate this exact number times 48 and then round off your answer, this is going to be a more accurate answer for finding out how much you have to pay for that gas. Okay, we had that twice. Okay, then you got up and walked around and thought about the situation, paired up with a partner and shared your thinking. The first one was, should you estimate high or low for each situation and explain your choice? And this one was about how much food you need to plan your birthday party. And all of you, when you paired up, all said that you'd want to definitely estimate high because it'd be embarrassing to run out of food for your guests at your birthday party. So you'd estimate high. In the second situation, you were estimating how much weight a bridge can hold before it's overloaded, and all of you agreed you'd want to estimate low for safety's sake. Who would want their bridge to fall apart because there was too much weight? Not a good thing. Estimating how long it's going to take you to do your homework, you all agreed to estimate high so you're sure to finish it and not run out of time and go to bed so late. In estimating how many kilometers your car can go before it runs out of gas, you all agreed to estimate low because you don't want to run out and get stranded. And then if you owe some money and you don't have the exact change, most of you said you have to estimate high to be sure you can fully pay your debt. One group didn't quite understand this. They thought this was money you were earning, so they said to estimate low. But if you owe that money, you definitely want to make sure you have enough to pay off your debt, so you'd want to estimate high. Okay, then we talked about negative numbers, and remembering that negative numbers, as you move to the right, you get closer to 0. So negative 5 is bigger than negative 6. And so we just talked about how you round those off on a number line to the nearest integer. So negative 5.138 is definitely closer to negative 5. And negative 5.138 to the nearest tenth is closer to negative 5.1. And to the nearest hundredth is closer to negative 5.14. So you round them off the same way, but when you visualize them on a number line, you have to make sure you put those numbers in the correct order on the number line. And then you have some practice to do. So either choose the basic or the challenge. Make sure you fold your paper vertically and show all of your steps. If you round something off, make sure you show what you rounded to before or after